Hello and welcome ulit dito sa ating static of rigid bodies. So yung topic naman natin ngayon is about sa another vector operation, which is yung tinatawag nating multiplication of vector. So dun sa mga nakaraang mga topic natin, yung pinag-aralan natin is addition of vector. Ngayon, lilipat tayo dun sa isang operation na pwede nating pakinabangan dito sa static of rigid bodies, which is the multiplication of vector. So sa multiplication of vector, mayroon tayong dalawang operation na ginagamit dyan. So yung una is yung tinatawag natin na dot product, tapos yung pangalawa is yung tinatawag natin na cross product. So magkaiba ito, parehas silang multiplication pero magkaiba yung kanilang ginagamit na operation. Patatandaan lang natin dito sa multiplication of vector na ito na yung ating vector A at yung ating vector B ay parehas na vector. Kaya natin siya tinawag vector A and vector B. So magkaiba kasi kapag scalar A and vector B. So magkaiba kasi yan. Yun yung example natin ng kauna-unahang topic natin dito sa static rigid bodies. Okay. So syempre, unahin natin yung dot product. So sabi kasi dyan, occasionally in the statics, one has to find the angle between two lines or the component of force parallel and perpendicular to a line. Sabi dyan, in two dimension, this problem can be readily solved by trigonometry since the geometry is easy to visualize. However, sabi dyan, in three dimension, karaniwan na ito ay mahirap na intindihin. So kaya tayo gumagamit ng vector operation, which is yung dot product. So sa dot product, yung equation natin is written as A dot B. So syempre, para ito ay ma-recognize natin as Cartesian vector form, lalagyan ulit natin dito ng row yan. So ibig sabihin parehas sila na Cartesian vector form. So yung dot product pala is yung dot product ng A, vector A sa kanyang vector B is equals daw yan sa magnitude of A times the magnitude of B multiplied by cosine theta kung yung theta natin is in between doon sa ating two vector. So ito yung magiging operation natin para doon sa dot product. And meron tayong mga law of operation para dito sa ating dot product. Meron tayong tinatawag na commutative law. No? So yung commutative law, ibig sabihin nun, yung A dot B ay equal din siya sa B dot A. So kung ano yung makukuha natin doon sa operation natin para sa A dot B ay ganun din yung makukuha natin doon sa makukuha nating result doon sa B dot A. And then we have the multiplication by scalar. Ito yung napag-aralan natin ng unang mga lessons natin. Once na multiply natin yung ating scalar doon sa ating vector, so namamagnify lang yung quantity ng ating vector doon sa amount ng ating scalar quantity. So ganun din dito sa dot product. So halimbawa meron tayong scalar A multiplied by vector A dot B. So ang result niyan is maaaring ganito. So A multiplied by scalar A multiplied by vector A dot vector B. Or po pwedeng A dot scalar A multiplied by vector B. And then we have the distributive law. Pwede rin natin gamitin yan na kapag yung A dot quantity B plus D, pwede natin i-distribute yan. Pwede siyang maging A dot B plus A dot D. So distributive property. Okay? So halimbawa, mayroon tayong vector A and vector B. Vector A and vector B. And syempre yung vector A natin is equals to AXI, AYJ, saka AZA. And yung vector B natin, syempre, equal yan sa BXI, BYJ, saka BZK. Ngayon, pwede natin i-apply yung distributive property ng ating dot product. Kasi dot product ng operation na ginagawa natin dito. So pwede natin sabihin na yung AXI or AX, BX multiplied by I ng ating A times the I ng ating B plus meron tayong AX times yung ating BY multiplied by yung I ng ating A, then yung J ng ating B plus meron tayong AX times BZ multiplied by K, I and K. So kung tayo sa second term, meron tayong AY multiplied by BX. So yung ating variable is J and I, that I. And plus, so second term, A, Y, BY, and then we have yung variable natin, which is J multiplied by yung BY natin, meron din siyang J. Then plus, we have the third term dun sa ating B. Meron tayong AY times BZ multiplied natin yan sa J and K. And then yung last term natin is AZ multiplied by BX. AZ, BX. So meron tayong A and I plus yung ating second term is A, J, BY. Then we have A and J. Yan. Plus yung ating last term AZ and BZ. And then yung ating variable is K.K. So mula dun sa unang pila natin na yung ating dot product A.B is equals to AB cosine theta. So kung ano man yung maging value ng ating A at B, so depende yan dun sa magiging variable natin dito sa nakuha nating equation na ito. Halimbawa, yung theta natin, if theta is equals to 90 degrees, so what will be the value of A dot B? Ano kaya yung magiging value ng ating dot product? So kung yung theta natin is equals to 90 degrees, so try natin i-calculate. So mayroon tayong cosine 90. So cosine 90 is equals to 0. Ibig sabihin, whatever be the value of A and B, kapag yung theta natin is 90 degrees, ibig sabihin A dot B natin is 0. If yung theta natin is equals to 0. Kung yung A and B natin ay unit vector, ano kaya yung magiging value ng ating A dot B? So try natin. So meron tayong cosine 0. So yung value ng A dot B natin is equals to 1. Okay. So kung titignan natin dito sa nabuo nating equation dito, we know that this is equals to A dot B. This one is equals to A dot B. So makikita natin dito, papansin natin, dito sa unang term meron tayong I and I. So ibig sabihin yung ating axis is parallel. So kapag yung axis natin is parallel, let's say ito yung I, nandyan yung isang vector, tapos nandyan din yung isang vector, parallel siya dyan. So ibig sabihin yung angle between that vector is equals to 0. So kapag nakita naman natin I and J, ibig sabihin, let's say ito yung I natin and this is our J. So malamang yung angle between that two vector is 90 degrees. So ito pala, yung I and I ay 0 yan, 0 degrees yan, yung pagitan yan. Tapos yung magkaiba ang variable, let's say I and J, ang pagitan yan is 90 degrees. So same din dito sa I and K, malamang pagitan ng dalawang vector na ito is 90 degrees. Ito rin, malamang pagitan nito ay 90 degrees. This one is 0 degrees, this one is 90 degrees, this one is another 90 degrees, then another 90 degrees, and this is 0 degrees. So from that, dahil sabi natin kapag 90 degrees daw, ang makukuha natin sa dot product is 0. So ibig sabihin, pwede na pala natin sabihin na lahat ng 90 degrees is equals to 0 kasi any number multiplied by 0 is equals to 0. Ibig sabihin, lahat ng 90 degrees dito ay magiging 0. Yan, 90 degrees, magiging 0 yan. So ito rin, 90 degrees, 0, 90 degrees, magiging 0, 90 degrees, magiging 0. So from that, maiiwan yung AXI, ay AX, sabi dyan, na A.B ang ating vector is equal na pala siya sa AX, BX, and yung ating variable is parehas na I plus AY, BY, AY, BY times J dot J plus AZ, BZ times A dot A. And we know that kapag 0 yung ating degrees or yung ating angle between two vector, so ang nakuha nating value ng A dot B or ng dalawang dot product ng dalawang vector is equals to 1. So ibig sabihin, ito is pwede natin equal yan to sa 1. Ito equal din natin yan sa 1. Equal natin yan sa 1. So kaya nagkaroon ng formula, yung A dot B pala is equal din sa AX, BX, tapos plus AY, BY, plus AZ, BZ. So ito lang pala yung tatandaan nating formula kapag yung ating given vector is in Cartesian vector form. So pag naka-Cartesian vector form siya, ang dali nang makuha yung AX, yung BX, AY, BY, and AZ saka BZ yung ating dalawang vector. So tatandaan lang natin itong formula na ito. So saan natin gagamitin yung dot product natin dun sa static of rigid bodies natin? So, paano natin papakinabangan yung dot product? So mayroong dalawang common application yan. So yung una is to determine the angle between two vectors. And using yung dot product, madali daw natin madidetermine angle between two vectors. And so gamitin lang natin yung formula natin na A dot B equals to AB cosine theta, saka yung isang A dot B is equals to AX, BX plus AY, BY plus AZ, BZ. So gamitin lang natin yan. Pwede na natin makuha yung angle theta ng ating dalawang vector. Yung isang application yan. Yung pangalawang application yan is it is used to determine the component of vector parallel and perpendicular to a line. So halimbawa, ito yung vector natin and we want to get the component of this vector A parallel to line A. So gamit yung dot product, pwede rin natin makuha yung component natin dyan, yung component parallel to line A. So yung component of vector A parallel to A in Cartesian vector form. So ito yung gagamitin nating notation, A subscript A na mayroong arrow sa ibabaw. Siyempre yung A na yon is scalar and yung unit vector na yon is the unit vector parallel doon sa ating reference line na A dash A. Ito yung A dash A natin. So yung unit vector ay manggagaling dito sa A dash A natin. And sabi dyan sa isang theorem, sabi dyan na yung ating scalar magnitude ng ating component parallel dun sa line A is equals to the magnitude of vector A multiplied by the cosine theta. Ito yun, yung theta natin. And that is also equal to the vector A in Cartesian vector form, that the unit vector of A parallel to the line A. So yung dot product pala ng ating Cartesian vector A saka yung unit vector A dun sa line na yun is also equal to the magnitude of A dun sa component parallel dun sa A. And dahil triangle yung nabuo natin na figure dito, so pwede natin gamitin yung Pythagorean theorem para makuha naman yung component of A perpendicular doon sa ating line na A dash A. So using yung Pythagorean theorem, so mayroon tayong A perpendicular to line A, or yung magnitude of the force or vector perpendicular to A is equals to the square root of the magnitude of the vector A square minus the magnitude of the line of the vector parallel to A. square. Okay? So, ito yung mga notation natin. Yung A natin na mayroong arrow sa ibabaw at may subscript na A is the Cartesian vector parallel to A, or the component of the Cartesian vector parallel to A. Ito yun. Okay? While yung ating A na may subscript na A, ito, is the magnitude of component parallel to A. So, naka-scalar yan. And then, yung A na mayroong perpendicular sign is the magnitude of component perpendicular doon sa ating A, or pwedeng ito rin yung distance na yan, or pwedeng ito, equal lang sila. So, yan yung ating A na mayroong perpendicular sign. And then, yung UA natin is the unit vector parallel to A. So, paano natin i-apply yan? So, para maintindihan natin, tingnan natin sa example. Okay, so unahin natin yung simple application ng ating dot product. Sabi yan, it is used to determine the angle between two vector. So tandaan lang natin yung formula natin, yung A dot B natin is equal yan sa AB cosine theta. Okay, so dito sa case natin na to, so mayroon tayong vector A. Yung vector A natin is mayroon siyang component na 5i plus 5j. Then yung vector B natin is mayroon siyang component na 8i minus 4j. Yan. Okay. So kung kukunin natin yung A dot B niya, yung isa pang formula natin para sa A dot B is simply the AX BX plus AY BY. So dito, yung A dot B natin is equal sa, meron tayong AX, yung AX natin is 5, meron tayong 5, and then yung BX natin is 8, meron tayong 8, plus yung AY natin is 5, multiplied by yung ating BY, which is negative 4. Okay, so meron tayong A dot B. No, siyempre, this is in Cartesian vector form. No? Yung A dot B natin in Cartesian vector form, pero yung makukuha nating value rito is scalar. Kaya itong dot product pala is tinawag din itong scalar product. Scalar product. Kasi yung nakukuha nating value, yung nakukuha natin sa operation na to is always scalar. Okay, so kung i-compute natin ito, meron tayo 5 times 8 plus 5 times negative 4. So, ang sagot natin is 20. So, makikita natin scalar yung makukuha nating value. Okay, so kung 20 yan, pwede natin i-equate dito sa first equation natin. Let's say this is the equation 1. This is the equation 2. So, equate natin yan dun sa equation 1 natin. So, meron tayong 20 is equals to A, B, cosine theta. So, ano yung A, ano yung B? So, siyempre yan yung scalar value ng ating vector A and ng ating vector B. Tingnan natin, yung scalar value ng ating A is equals to square root lang yan ng 5 squared plus 5 squared. 5 squared plus 5 squared. So, yung scalar value ng ating vector A is square root of 5 squared plus 5 squared. So, meron tayong 7.071, while yung ating scalar value ng ating vector B is equal sa meron tayong 8 square plus negative 4 square. So yung scalar value niyan is equals to square root of 8 square plus 4 square. So meron tayong 8.944. Substitute lang natin dito. So meron tayong 20 is equals to yung A natin in scalar form is 7.071 multiplied by yung B natin in scalar form is equals 8.944 times cosine theta. So from that, makukuha natin yung theta, which is equals to inverse cosine ng ating 20 all over 7.071 times 8.944. Okay? Yan, inverse cosine. Tama ba? Okay, so tama. So meron tayong inverse cosine of 20 over 7.7071 times 8.9 more data natin is equals to 71.56 degrees approximately. So ito yung isang pakinabang ating dot product. Although kasabihin niya may mas madali pang paraan dyan. Yes, may mas madali pang paraan dyan. Using trigonometry, pwede natin ma-solve yung data dito. Data kasi using inverse tangent, makukuha na kagad natin yung theta A sa yung theta B. And then isang lang natin yung theta natin. So ganun lang siya kadali. Kapag two-dimensional yung ating force system. Yan din yung comment dun sa unang slide natin. So madaling ma-solve yung angle between two vector kapag two-dimensional yung ating force system. Kaya lang ang problem, pag three-dimensional na yung force system natin, medyo mas mahirap. So siguro i-try lang natin na i-solve ito using yung geometry o yung trigonometry. So kung kukunin natin yung theta A, so meron lang tayong tangent theta A is equals to the opposite over the adjacent. Simply, yung opposite natin is 5 and then yung adjacent natin is 5. So makukuha kaagad natin yung theta A na 45 degrees. So shift tangent or inverse tangent of 1 is equals to 45 degrees. Then we have tangent ulit ng theta B naman. Kung titignan natin, yung opposite natin is 4, yung adjacent natin is 8. Okay, so yung inverse tangent ng 4 over 8 is equals to meron tayong 26.565. So pag pinag-add natin yung theta A plus theta B, so that is equals to plus 45 71.565. So almost equal siya rito. Okay. So makikita natin mas madaling i-solve kapag ginamitan natin siya ng trigonometry. So naging mas madali lang i-solve yan dahil yung ating force system or yung ating system is two-dimensional. Pero kung yan ay three-dimensional, mas madali siyang i-solve kapag ginamitan natin siya ng dot product. Okay? Okay, so another example tayo. I-apply natin yung isa pang application ng ating dot product. So sabi dyan, the frame shown is subjected to a horizontal force F is equals to 300J. Determine the magnitude of the component of this force parallel and perpendicular to member AB. So ibig sabihin, ang kukunin natin na reference line is yung member AB. So kukunin natin yung component, this force, itong F na 300J, parallel dito sa AB, saka perpendicular dito sa AB. Okay? So isang parallel sa isang perpendicular. So paano natin kukunin yan? So sabi natin kanina, yung ating formula is equals to A is equals to A cosine theta, which is also equal to A in Cartesian vector form, dot unit vector along A. So ito is yung AA natin, kung matatandaan natin, ito ay yung magnitude of force parallel doon sa ating reference line. In our case, yung reference line natin is yung line AB. Ibig sabihin, itong AA natin, papalitan natin yan ng force AB. So yan pala yung force AB is equals to, so ito hindi muna natin gagamit ito muna yung gagamitin natin. The Cartesian vector of vector A. So yung vector A natin dito, hindi naman vector A yung given. Ang given is vector F. Yung vector F natin, ito siya. Yung vector F natin dapat naka-Cartesian vector form. So luckily, yung ating vector F is naka-Cartesian vector form. Okay, so instead na A yung ilalagay natin, ang ilalagay natin is vector F. Then that product ng ating unit vector A. Yung unit vector A natin is along line AB. So dapat yung subscript natin instead na A, kasi kanina line A yung ating sinusundan. So yung subscript na natin is line AB. So mula dyan, meron na tayong given na vector F. Meron na tayong vector F. So yung vector F natin is equals to in Cartesian vector form na agad siya. So meron tayong 300J. So hindi na natin poproblemahin dito. Ang poproblemahin na lang natin is the unit vector along line AB. So ano yung unit vector along line AB natin? So para makuha natin yan, gagawa lang tayo ng daan mula dun sa point A papunta dun sa point B. Make sure na dadaan tayo dun sa I, J, and K axis, o dun sa X, Y, Z axis natin. So para makarating tayo dito sa point B, ang muna nating dadaanan is yung ating X axis. So isang pag ganon, then susunod meron tayong pag ganon, and then aangat tayo pag ganon. Okay? So from that, yung ating position vector from A to B is R from A to B is equals to, mayroon tayong path mula dun sa A along X na 2. So meron tayong 2I, and then meron tayong path mula dun sa dulo ng ating first component papunta dun sa ating second component na positive 6J, and then we have yung ating Z na positive 3K. So ito yung ating Cartesian vector para sa ating position vector along AB. So para makuha natin yung ating scalar form, so kunin natin yan, 2 square plus 6 square plus 3 square, then square root natin. So kung isosolve natin yan, scalar natin para sa position vector AB, this is AB pa rin. O kinuha natin to para makakuha tayo ng unit vector, kasi alam natin yung unit vector is equals to position vector in Cartesian vector form divided by position vector in the scalar form. So ito yung in scalar form natin. So meron tayong square root of 2 square plus 6 square plus 3 square. So meron tayong position vector na 7. So kung kukunin natin yung unit vector ng AB natin, so equal yan sa 2I plus 6J plus 3K all over 7. Or pwede nating sabihin na this is 2 over 7I plus 6 over 7J plus 3 over 7K. Itong unit vector nito, may multiply natin siya or ikukunin natin yung cross product niya kay vector F. So sabihin, yung force or yung magnitude ng FAB is equals to the force vector natin F is 300J. So idadat product natin yan kay unit vector na 2 over 7I plus 6 over 7J plus 3 over 7K. And we know that that product of that is meron tayong AX, di ba? So yung halimbawa meron tayong vector A and vector B, and that product natin is AX BX plus AY BY plus AZ BZ. So in our case, yung vector A natin, ito yung vector B natin, portion na to. So yung vector A natin, yung AX niya ay 0, and then yung BX natin, ito is 2 over 7 plus yung AY natin is 300 times yung BY natin is 6 over 7, and then plus yung ating AZ is 0 again, multiplied by yung ating BZ is 3 over 7. Okay, so mula dyan makukuha natin na yun palang FAB natin is equals to 300 times 6 over 7. So yung magnitude pala ng ating force parallel dun sa ating member AB is equals to 257.142 Newton, kasi Newton yung unit natin. Okay, so ito yung parallel. parallel to AB. So yung perpendicular to force AD, gagamitin lang natin yung formula natin na Pythagorean theorem na andun na rin sa naunang slide, which is equals to yung force perpendicular to AB. Gagamitin natin force perpendicular to AB is simply the square root of F square minus yung ating parallel to AB. So FAB square. So kunin muna natin yung F natin. Yung F natin in scalar form is equals to 300 square. So tapos square root nun, malamang 300 pa rin. And then yung ating FAB is 257.142. So yung F, this one is equals to square root of 300 square minus yung ating parallel is 257.142 square. So F perpendicular to AB is equals to tayong square root of 300 square minus 257.142 square. So meron tayong 154.52 Newton. Okay? Okay, so another example tayo. Sabi rito, the pipe in the figure is subjected to force of 800 pounds. Determine the angle between F and the pipe segment BA. So, angle between F, this one, and yung ating pipe na BA. So, kunin natin yung theta. And the pipe segment BA and the force acting in this segment. So, ano yung force na nag-a-act dun sa member na BA? So, susolve natin yan using that product na naman. So, ang una natin isosolve is yung ating angle between two vector. So, paano natin makukuha yung angle between two vector nito? So, siguro kunin muna natin yung position vector ng ating line AB, position vector ng ating AB, saka yung position vector ng ating AC. Okay, so ito yung gawin nating reference. Say this is our reference. So, pag galing tayo sa B, magta-travel tayo papunta sa A. So, mayroon tayong dadaanan na negative 2 feet. And then, mayroon tayong dadaanan na positive 2 feet ulit. Ganun, along Y. And then, saka tayo dadaan sa ilan to? Positive 1 feet. Tataas tayo ng 1 feet. Okay, so lagyan natin ang value yung dinaanan natin. So meron tayo rito negative 2, and then we have another negative 2, and we have positive 1. Ibig sabihin yung position vector natin from B to A yan. So gagawin natin yan. Sulat dapat natin is from B to A. Ibig sabihin, nag-travel tayo from B papunta sa A, dumaan tayo sa x-axis, dumaan tayo sa y-axis, dumaan tayo sa z-axis, or dumaan tayo sa I, J, and A. So, yung ating x-axis is negative 2, I, and then we have negative 2, J, and we have positive 1, A. Ngayon, kay RAC naman, parang parating tayo, galing tayo RBC, BC. Galing tayo sa B, pupunta tayo sa C. So, mula dito sa B, magta-travel tayo ng ilan to? Okay, so sa x-axis natin is 0. Wala tayong travel. Then sa y-axis natin, magta-travel tayo ng distance na Mayroon tayong 2 feet plus 1 feet, so mayroon tayong 3 feet. So yung tinravel natin is negative dahil against dun sa flow ng ating positive. And then, travel tayo upward ng 1 unit, 1 positive. Okay, so mayroon tayong unit vector na 0, I, negative 3, J, and then positive 1, K. Okay, so ito is in Cartesian vector ulit yan. So makukuha natin yung scalar nito, BA, and then R, BC. Pero mula dito, kasi ang kailangan lang natin is, yung unang kailangan natin is angle between two vector. So naka-Cartesian vector na yung ating position vector. So possible na makuha natin yung angle between two vector. So yung formula natin, A dot B, let's say A dot B is equals to AX BX plus AY BY plus AZ BZ. So yung A dot B natin dito is hindi A dot B. So mayroon tayong R BA dot R BC. That is equals to, so mayroon tayong 0 times negative 2 plus negative 3 times negative 2 plus mayroon tayong 1 times 1. So yung ating RBA dot RBC is equals to, so mayroon tayong 3 times, so mayroon tayong 7. Then yung formula natin na AB cosine theta is equals to 7. So in our case, yung AB natin, yung A natin in scalar is solve natin 2 square plus 2 square plus 1 square. Then square root ng answer. So meron tayo ditong 3. Then 2 square plus 1 square. Square root ng answer. So meron tayo ditong 3.162. Okay. So meron tayong 3 times 3.1622. 1622. Yan. Divide by applied. So meron tayong 7. So 7 divide by 3 times 3.1622 is equals to cosine theta. So yung theta natin is equals to, so meron tayong 7 over 3 times 3.1622 plus inverse cosine. So meron tayong theta is equals to 42 degrees. Okay, ibig sabihin yung angle between force F saka dun sa ating member AB is 42.45 degrees. Ngayon, kung may angle na tayo, madali na natin makukuha yung magnitude ng force dun sa member AB, force dun sa member AB. Kasi sabi natin dun sa formula natin kanina, yung AA is equals to A cosine theta. Pero yung AA natin is the force parallel dun sa ating reference line. Okay, and yung ating A is the magnitude of the given force vector. So madali na natin siyang kasusot. I-substitute lang natin yung magnitude ng ating force vector is 80, and then we have cosine, yung theta natin is 42.45 degrees. So FAB is equals to, compute na lang natin, 80 times cosine 42.45. So meron tayong 59.029 unit natin is found. So ganun siya kadali, kapag alam natin yung dot product. Pero kung di natin alam yung dot product, medyo mahihirapan tayong i-solve ito. Okay, so yun yung advantage ng paggamit natin ng dot product. Madali natin makukuha yung angle, madali natin makukuha yung component along doon sa given line o perpendicular doon sa given line. Okay?